In this video we'll be looking at the Baby Website Rick challenge on HackTheBox. It's an easy web challenge and the description says, "Look Morty look, I turn myself into Website Morty, I'm Website Rick baby. But don't play around with some of the anti-pickle serum I have stored somewhere safe. If I turn back into a human I'll have to go to family therapy and you don't want that, Morty." So obviously a reference to Rick and Morty. Let's start an instance here, which I should always do before reading the description, but let's go. Okay, we load the page, we see here Website Rick and an animation of Rick, and there's some text here saying don't play around with this serum, Morty, and an address here saying main.antipickle serum object at an address. Let's refresh that, see if there's any change to the, yeah, okay, so the address is changing each time. Let's view the source. A lot of animation stuff there, but doesn't appear to be anything else of interest. Have a look in the developer tools here. See what we have. Do we have any cookies? We have a cookie here, plan B. Let's take a copy of that and go into Burp Suite and into our HackVerter. You can see it's auto decoded that, and we have here what looks like a pickle object. So if we have a look here at Python pickle, and we can see that the pickle module implements binary protocols for serializing and deserializing Python object structure. So if we look for deserialization, security, safely load a pickle file, and we see here the Python manual comes with a warning about the pickle module. The pickle module is not secure against erroneous or maliciously constructed data. Never unpickle data received from an untrusted or unauthenticated source. So it looks like a deserialization vulnerability from here. So let's look and see if we can find out more about this pickle object. So there is a pickle module in Python. Let's minimize this and check it out. If we do python-m PickleTools, do I have it installed? Yes. PickleTools, disassemble one or more pickle files, and it takes in a pickle file, and we can also use annotate to annotate each line with a short opcode description. So let's create a pickle file, and something from the previous video. Let's we need to grab our string here. I'm not too sure, does it take it as a base 64 encoded string or not, so we'll grab it here, and then let's see if we can base 64 decode it on the way if we need to. So python-m PickleTools, and then we'll just pass in the file to begin with. Pass in pickle. Okay, didn't work for us. Let's try to let's base 64 decode pickle and save that to pickle2, and let's do that with pickle2, and now we get our result here. So we have the same similar sort of structure that we have here. We can see that there's a serum string s, and then we have this global reconstructor. We have another object here with the main anti-pickle serum and built-in object. Let's run that again with the annotations, because I don't know much about pickling or pickles. And it's saying here that, yeah, it's building a dictionary out of the topmost stack slice, store in a top stack, push the Python string serum. We're pushing then this object, so it's creating a dictionary. It's pushing two objects to the dictionary, this anti-pickle serum and this object as well. Okay, so let's have a look and see what what kind of exploits are available for this. So I'll leave some links to some good write-ups on this challenge in the description. If you go through those write-ups, anything that I've missed or not explained very well will probably be explained better there. You know, it's just if you'd rather go through the video and kind of see it actually being done, that's why I'm putting this out there. So this article anyway, it explains to us what a pickle is, allows us to serialize and deserialize data, meaning that we can convert a Python object into a stream of bytes and then reconstruct it. It also explains that it's not secure and we should only unpickle data that we trust. It goes into describing how to dump and load pickle data. So let's try and open up a Python file here. Let's create test.py to begin with, and let's import this. Now, in the example here, we're doing the pickle dump, but let's go and see. Here we have the pickle loads, so let's grab that, and let's say we can import base64 decode here, or you can import PickleTools as well. PickleTools has a lot of useful functions. From pwn import all, has a lot of useful functions in it, including the ability to just base64 encode and base64 decode quite easily. So we can base64 decode in this example our cookie value. Whereabouts is it? Okay. Grab this cookie value and we'll paste that in that. And let's try to run, in this case it is our serum. Let's actually go back and keep this open in case we need to. So this is our object here, the serum. Inside it we have the anti-pickle serum and then this object as well. We'll say serum equals pickle loads, and then let's try to print out the serum. Keep that open, so we'll go and do Python test, and we get this error: can't attribute anti-pickle serum, can't get attribute anti-pickle serum on module main. So let's go back and we'll try to add a anti-pickle serum here. Let's grab this anti-pickle serum. You'll notice that in here this was set to, we had this push a global object, so we'll just say anti-pickle serum equals test. Let's try that again. And now we get this new error to say that the object new x is not a type object string. So in this case we can make it a class extending from object. So instead of having this as a string, we'll have here a class. And set this to try and run that again. And now we get that the serum is an anti-pickle serum object without any errors. So let's go back to our exploit guide here. This mentions how to use PickleTools as well to dump those out. PickleTools, and let's actually grab this and we're gonna say PickleTools. What did it take there? It took the dumped object, so this is already dumped. Okay, so let's say before we print the serum, let's also print this as well. And I'm gonna say original pickle is equal to, let's actually base64 decode it there as well. We're going to load the original pickle, and I just want to see how this original pickle shows here as well. Does it show the same? It might just show the same thing as we saw here. It does, yeah. Okay. Cool. Let's it's the same thing. We just also used the -a flag previously, but that's cool. Let's go back to our guide here. It says in controlling the behavior of pickling and unpickling, not every object can be serialized. For example, file handles. And pickling and unpickling certain objects like functions or classes comes with restrictions. Python docs give you a good overview of what can and can't be pickled. It mentions down here that implementing a reduce function is exactly what we'd need to get code execution when viewed from an attacker's perspective. So it says that the reduce method takes no argument and shall return either a string or preferably a tuple. When a tuple is returned, it must be between 2 and 6 items long. Optional items can either be omitted or none can be provided as a value. And it says here that the reduce will take a callable object that will be called to create an initial version of the object, and then a tuple of arguments. An empty tuple must be given if the callable does not accept any arguments. Okay. So, by implementing a reduce class in a class which instances we are going to pickle, let me say that again. So, by implementing reduce in a class which instances we are going to pickle, we can give the pickling process a callable plus some arguments to run. While it's intended for reconstructing objects, we can abuse this to get a reverse shell. Okay, so they set up a vulnerable application here. We already have a vulnerable application, so we don't need to worry about that. Crafting the exploit is going to be the important bit. So here they've created a class called RCE, remote code execution, and then they have implemented the reduce method, takes in self, and then it has a command, in this case reverse shell command, and it returns OS system and then the command. So as was mentioned, it takes a callable object, it returns a callable object and the parameters. In this case the callable object is system and the parameters are whatever command we want to run on system. And then if this is dumped, if this is deserialized using a pickle, then this code should execute. It should return OS system with that command. So let's see how we can incorporate this with our code. So we need to create, we have this init. Let's create a def reduce self, and let's pass in, I'll grab a copy of this, but we'll change the command anyway. Okay, we'll change this command to ls for now. and it's going to return os.system and the command let's import os. Okay. That looks fine. So let's not. Yeah, let's. That's our original pickle. What we want to do now is dump this class. So let's say serum is pickle.dumps and anti-pickle serum, and then let's print that out. We want to base 64 encode it, so B64E, and see what we get. So if we run that now, Python test, we get back a base 64 encoded value. Let's go and test it out. If we set this as our cookie, refresh the page, and we get an error. Okay, let's dump that out without the base 64 encoding, see how it looks. And you'll see it looks quite different to our original code. Our original code, whenever we dumped it, was, do we have it in burp still? It looks like this. Quite different to the hex values and stuff we have there. So let's see if it's mentioned at all on this page. The protocol. This, you see this highest protocol among opcodes is set there, and it's set as 4. If we go and check for our example, it was set to 0. So let's go back here, and we have the pickle dumps. Does it? It doesn't. Okay, yeah. Trying to get the example of parameters up. So it takes an object and it takes a protocol. And if we go there, it doesn't give the examples of the protocols there, but okay, that's fine. Let's try and set the protocol then to 0. And let's run it again. Okay, and that looks a bit better. We see the NP1, you know, it's kind of a similar format. Bear in mind that obviously this has the new lines for this example. It would look more similar to that example. So let's base 64 encode it and try that out. B64E. We run that, grab our base 64 encoded value, and let's go back to our cookie, paste it, and refresh the page, and that still didn't work. The reason being, we have created our anti-pickle serum, which is based on the object right here, and we've put in our reduce method inside it to execute our code. We put in the init, which was required just to get it to run. But we also had this string, so if you remember, this was a dictionary. You see here dictionary, and the serum is the key, and then these objects are the value. So actually what we need to do here is say that this is a dictionary, and the dictionary is named serum, and close, and the inside the dictionary is the anti-pickle serum. Let's try that out. So we run that, we get a different base 64 encoded value. We enter that into the cookie and refresh, and we get don't play around with the serum Morty. So we're getting somewhere, and we also see there a 0. So this is because this is the return value of the system function. So what we need to do is use a function that's going to return an output for us. So let's change this to import subprocess. We'll use this instead of the OS system command, and then right here we'll say return subprocess dot check output, which will run a command with the arguments and return its output as a byte string. So we'll run check output, and then we want to pass in the command. So it needs to be as a tuple of parameters there, as you can see. So let's try that. Run that again, grab the new cookie, and if you paste this in here and refresh, oh, we get an error. Okay. Let me see if we need brackets here. Try that. And refresh. No. Let me try. Maybe without the init, but we needed the init earlier on to run that. Let me try without it. Okay, so it doesn't make any difference to the actual pickle anyway. Okay, I'm gonna try this with Python 2. PN2 and no source PN2. Let me try that again. Okay, is that different result to our Python 3? Let's have a look. Paste that in. Refresh. It was, yeah. Okay. Okay. Props to Ironstone. Found that on his walkthrough, which I'll link in the description as well. Great walkthrough on this, along with another one which I found particularly helpful. So that listed the directory for us. We can see we've got the app.py, we've got this flag file, and then our static and templates folder. So pretty obvious what we would try to do next. Let's set our command to cat and this flag. Let's run that again, make sure we're using Python 2, and paste the new cookie, run that again, and we don't get our flag because we need to pass this as a list of parameters. So cat, and then let me just double check that. Yeah. Okay. Paste that. We'll save it. And run that hopefully one more time. Go back to our... Oh, we have no cookie now. Okay. Let's go to our burp suite. Let's send this to the repeater, and then in the repeater let's paste in our new cookie. Oh, let's grab the cookie again. And paste it in. Send. Error encountered. Okay, let's send. Alright, it's back up and running by the looks of it there. Let me open this in the browser. Show response in browser. And it's not seeming to be able to find this. Let me... Oh, there we go. It's back. Okay. It's back. Let's refresh the cookies. I'm really confused. Where are the cookies? Okay. Let's add a new cookie. Plan B. We can't add a new cookie here. We need to set it to equal base 64 encoded value. Add it. No. Okay. I thought you were able to just add cookies here, but apparently not. And I guess we have no cookies either set here. Although, let's refresh that again. We refresh. Yeah, the cookie's in burp, it's just not in the Firefox tab. Oh, there it is. Okay. Apparently refresh didn't work. You actually have to reload the page. Oh, sorry. You had to close down the developer tools. All right. So there is a problem with that cookie. Let's see. It's because I'm putting it probably in the brackets here. Run that again. Paste that in there, and let's refresh, and there we go. Finally, we got the flag. Alright, a lot of problems with formatting and stuff there. But that's the flag. I hope you've enjoyed this video. If you want a better explanation of how to solve the challenge, you can check out this write-up from Ironstone, which goes through basically everything I've been through in the video, probably in a more structured and better explained way. There's also this one as well from Brain Coke. Again, very well explained, lots of detail. I'd recommend checking them out. And any questions, comments, leave them down below. Thanks.